And welcome to Climate Chat. I'm your host, Dan Miller. And Leon Simons will be joining us a little bit later. He's running a bit late, so that's fine. Hope to see him soon. Before we get started on today's subject, I just want to tell everybody that we're going to have a special guest on a special day this coming Wednesday, September 3rd, at our regular time, this time 10 a.m. Pacific time. Our guest is going to be Bill McKibben. Bill McKibben is probably, I'm sure he's the number one climate journalist in the world. He wrote the first book on climate change in the 1980s. And he's actually, so I'll talk to him about it when I see him, got me into climate change. I read one of his articles in the early 90s and piqued my interest. I wanted to learn more. And he has a new book out about solar energy and how revolutionary that is. It actually, there's some facts that you might not be aware of how impactful that is. And so it's going to be a great discussion this Wednesday. Please like and subscribe, turn on notifications so you don't miss it. And again, special day this coming Wednesday at 10 a.m. Pacific. So today's program is titled Venus Syndrome and Runaway Climate. Our guest 2 weeks ago was climate scientist James Hansen, as you know, probably the most renowned climate scientist in the world. And it was a great discussion. We covered three ways that we know that climate sensitivity, which is sort of how much the world warms for a given amount of CO2, greenhouse gases. And in this particular case, when you say equilibrium climate sensitivity or ECS, that means how much the world warms eventually from a doubling of CO2. So that's sort of like a unit of measure. Like you double CO2, how much warming you'll get. And that way you can compare different climate models, different predictions and things like that. But it's a real world number that has huge impacts on our lives because we've already emitted 2.6 trillion tons of CO2 and increased CO2 in the atmosphere by 50%. And when you throw the impacts of the other greenhouse gases, we actually already are at a doubling. But we're at 1.5 C of warming right now, not at 4.5, which is the prediction from Jim Hansen. And what is, so 4.5 C is absolutely catastrophic. But the thing is, we're on our way because, as Jim pointed out in his writings, you get about the first third of warming in the first 10 years. You get the next third in the next 100 years, and you get the last third in about the next 1,000 years. So we're on our way to more warming, especially since we're continuing to emit greenhouse gases. So it's even going to be, eventually more than that. Of course, we all care about what it's going to be in the next 75 years or so, and an ECS that's 50% higher than what the 3 degrees that the IPCC uses, or as their sort of standard value, is still mind-boggling. And this is all tied into the subject of aerosols that we spoke about in many previous programs. And Leon Simons is a co-author with Jim Hansen on the global warming and the pipeline paper, and he is sort of the world's expert on aerosols and the impact that has on the global climate. So, all that being said, Jim gave us 3 ways that he determined ECS is 4.5. First is looking at paleoclimate data or historical climate data. And in this particular case, looking at the last ice age and seeing how much colder it was back then. And we knew how much less CO2 there was back then. It was 180 parts per million instead of the more recent pre-industrial 280. And so you can do the calculations there. There was new data on the ice age temperature that revised it to be colder than previous estimates. And since it was colder back then with less CO2, that means it will be warmer now with more CO2. And again, when he does the calculations, it comes out to be 4.5 degrees Celsius. The second way was looking at the shipping experiment we did, where we lowered Oh no, I'm sorry. The second way was, well, that's one of the three ways, but the second way in order was using satellite data from the last 25 years about the albedo of the Earth, how dark the Earth is, and he found that the Earth has gotten 0.5% darker in the last 25 years, and that sounds like very little, but that's a mind-boggling huge amount. And when you do the calculations there, you also come up with a 4.5 degrees ECS, or equilibrium climate sensitivity. And then the third way was using the changes in aerosols from the shipping. The International Maritime Organization implemented rules in 2020 to lower the sulfur content of ship fuel, which everyone followed, lowered it by 80%. And then the temperature skyrocketed. By that, you can get an estimate of the impact of aerosols. And from that, using climate models, you can also get the impact, what the ECS is. So if there is more cooling than we thought from aerosols, that also means there is more warming than we thought from greenhouse gases. So those were the three ways. But during that interview, he hinted that he was going to come out with a writing soon. He said in the next week or so on a fourth way. And so he did that. And so he published what he says is his chapter 10 of his book, Sophie's Planet. For full disclosure, my sister is his editor for that, as he talked about during the interview. And so this is chapter 10, and it's titled The Venus Syndrome and Runaway Climate. So that's what we're going to talk about today, this fourth way of knowing what we're in for. So again, the three ways were paleoclimate data, looking at the albedo or reflectivity of the Earth from satellites. And the third way was recent temperature changes and looking at changes in aerosols and using climate models for that. So, and now this fourth way is looking at Venus and comparing it to the Earth and seeing what we can learn from that. So that's what we're talking about today. And it's actually, it's not going to take that much time to go through it. He doesn't provide the same level of detail that he does in a normal communication. And the reason for that is that he's writing this book, Sophie's Planet, which he wants to be accessible to sort of a broad public. And therefore, it doesn't get into like equations and stuff. And he says that in this writing, if you read it. Oh, by the way, the link to this communication is in the video description on YouTube, so you can access it there. And there's also a link to our recent interview with James Hansen. If you missed it for any reason, you definitely should check that out. Great interview with one of the top climate scientists in the world. So let's jump in. So he starts off by talking about a mistake he made. When he first wrote his first book, which I have up here somewhere on my, it's not easily accessible. It's called Storms of My Grandchildren. And this is actually a book I encouraged him to write. And so he wrote this book. And in it, he mentions the possibility for a runaway greenhouse effect that would make Earth sort of more like Venus. Now, so if you recall from our last interview a couple weeks ago with Jim, he mentioned if you take a look at Mars is 5 degrees Celsius warmer than it would be without an atmosphere. And one reason it has hardly any atmosphere. It's like 1% of the Earth's atmosphere. It does have a lot of CO2, but again, there's just not a lot of atmosphere. And so it's 5 degrees. And the Earth is 33 degrees warmer than it would be without an atmosphere. And that's a Goldilocks kind of number because it brings us from, I can't remember the exact numbers, but roughly minus 14 degrees to plus 16 or something like that. Celsius. So I think it brings us up to 57 on average, global average for the Earth, 57 degrees Fahrenheit. And so if it was less than freezing, the Earth would be a frozen snowball. And with greenhouse gases, it's a nice place to live, or it used to be. So But now you take a look at Venus, and Venus is 500 degrees Celsius warmer than the Earth. And you say, well, it's closer to the sun. Well, that's true, but it's also light colored because it has it's covered in clouds and light colored clouds. And so for that reason, it should be a little cooler than the Earth, which is sort of has a darker color, and yet it's closer to the sun, so it should be hotter because of that. And if you take those two things, they kind of cancel out, and everything, if it had the same atmosphere as the Earth, then it would be roughly within I think within 10 degrees Celsius, the same temperature as the Earth. But it's not. It's 500 degrees warmer, and the reason for that, which Jim discusses in this communication, is that first of all, it's like 96% CO2, and there's also a lot of water vapor in the atmosphere, and CO2 sort of traps a certain frequency or spectrum of infrared radiation or heat, and water vapor captures a different spectrum. So they sort of double team to capture heat, and it's a very dense atmosphere compared to the Earth. And so it would crush you if you were there. The atmosphere itself would just crush you, just like if you went to the bottom of the ocean, you get crushed. So there's really, really big differences. But he did say in this communication that he made a mistake in that original book, Storms of My Grandchildren, in that when you look at it in more detail, you see that there will not be a runaway greenhouse effect that turns Earth into Venus. So sort of the warming makes it warmer, and then eventually, he was saying in a few hundred years, like I think it was 400 years or so, 500 years, that the oceans could boil away off the Earth, which is what happened on Venus, by the way. It's a very, very dry planet because it's so hot and it's basically baked, and so no life on there. So he said that's wrong, and the reason is kind of rather technical, but the bottom line is because we have an ocean, and it turns out that we have a certain kind of hydrogen that's a little heavier than other kinds of hydrogen, and therefore it's harder for it to sort of escape the Earth, and that keeps our ocean sort of stable. And if we have a stable ocean, then we're not going to have a runaway greenhouse effect on like Venus has. So that's the good news. Wow. So we can just go, whoo. But he says we can still have a runaway climate, and a runaway climate that's very, very damaging for future, our children, as he puts it, our children and future generations. And we can learn that by looking at Venus and what's happened there, and looking at the Earth from a planetary perspective. And so, and also he's a little careful using the word point of no return versus tipping point. And the reason he does that, he said he used to use the word interchangeably, point of no return and tipping point. But there's a scientist that wrote a paper, Lenton, about tipping points, and he used it to describe a broad variety of amplifying climate feedbacks, some of which can be reversed if you cool off the Earth. So let's say you use solar geoengineering, solar radiation management, you cool off the Earth. Some of those things can be reversed. Others cannot. So like, for example, once there's an AMOC tipping, it's going to be hundreds or thousands of years before the AMOC comes back. And also, once you lose ice sheets, it's a lot easier to lose ice sheets than it is to gain them. So it takes, and as a little tangent, I watched a video came up in my YouTube feed yesterday, the mysteries of climate change. And it was this guy, Professor Riggs, I think is his name, who said, there's things we just don't understand. He says, like, look at the ice ages. Yeah, we know this thing called Milankovitch cycles, and we know that causes a little more heating now and then, every 100,000 years and whatever. But look, it gets warmer fast, and it gets cold slowly. and what's going on there, and we don't know. And yeah, they say it's CO2, but CO2 is lagging, it's not leading, and the whole thing is climate denial just packaged in a nice video, which unfortunately I have to say gets more views than our channel does. And so this is all kind of, I don't know, thinking about all of this. And we're going to do a show on molecular cycles coming up, and we'll maybe get into that kind of climate denial. The answer is we do know. It's not a mystery. And it's the molecular cycles causes warming, which causes more CO2, which causes more warming, which causes more CO2. So back to this, what Jim is saying. He says it's a point of no return. There's upcoming points of no return. And he doesn't use the word tipping point because those can be reversed. So these are things that cannot be reversed on human timescales. They can be reversed eventually, but not in any time that will matter to us. It might take hundreds of thousands of millions of years, hundreds of millions of years for some of these things. So anyway, what he thinks are the major points of no return for the Earth are enormous. I'm going to quote him here: enormous or irreversible consequences for today's young people and their descendants. I depicted the danger of rapid ice sheet collapse and sea level rise as a tipping point 20 years ago. But then he explains, now I call it a point of no return. He then talks about the runaway climate threat and danger of passing a point of no return are taboo with the United Nations Intergovernmental Panel on Climate Change, or IPCC, the organization that we should expect to be the most protective of the rights and futures of young people. So he said this is talking about points of no return is a taboo subject at the IPCC. And if you think about it, they do talk about tipping points, and now there's more papers on it, but this is not something that, they're sounding an alarm about, even though these things are way more, could happen much sooner than the IPCC says. So and then he continues, we have presented evidence that the millennial timescale of ice sheet changes in the models that IPCC relies on are much slower than indicated by real world data, even when the ocean and ice sheet changes are driven by very slowly changing paleoclimate forces. So there's sort of two things in there. One, he's saying that the ice sheets can melt faster than the IPCC says. But based on real world data, for example, the global warming that we're experiencing now is melting them faster than the IPCC is saying. But he's saying even the paleoclimate data, looking at the last ice age and coming out of the last ice age, that there was very rapid sea level rise during that, quote, natural switch using Milankovitch cycles and everything to go from the ice age to the interglacial time that we're living in now, and including meters, multi-meters per century. And that was with way slower forcings than we're pushing the planet now. We're pushing the planet. The CO2 is increasing at a rate I forget exactly. It's at least 10 times, if not 100 times faster than in any time in Earth's history. And so he's saying both the paleoclimate data says we should be alarmed about how fast sea levels can rise, because under natural forcing, way slower than what we're doing now, it still rose multi-meters at certain times during the interglacial, the transition to the interglacial. And also we're pushing it right now at a huge forcing, and we're seeing how much ice mass loss from Antarctica and from Greenland there is. And Jim, he didn't say it in this paper, but he said it in other times, that we could see multi-meter sea level rise this century, or in the next 100 years, let's say. So, 2100, 2025, multi-meter is 10 plus feet of sea level rise. That means the bottom third of Florida is no longer on the map. There's nothing over 15 feet there. And I just heard something, 75% of the land in the southern third of Florida is 5 feet or less. So, and then around the world, coastal cities, every major coastal city inundated, island nations, etc. And this is all stuff that the IPCC should be warning us about, but they're not. Well, I mean, they said they're warning in general, but not telling us like how serious, how soon, how much. Okay, so that's one of them. That's one of these planetary points of no return. The other are, he said, there is a more mundane, slowly growing climate threat, which the public is beginning to recognize. Extremes of the hydrological cycle or water cycle are amplified on a hotter planet. Where rainfall occurs, it includes more extreme rainfall, floods, and stronger storms driven by a warmer ocean, greater latent energy in water vapor, and larger temperature gradients. High temperature causes dry times and places to have more extreme heat waves, droughts, and fires. Some tropical regions and the subtropics in the summer can become so warm that the human body is unable to cool itself and survive in the outdoors. If we allow global climate to go down that path, pressures for immigration from low latitudes would dwarf the immigration pressures of today, which would likely make the planet ungovernable. So that is the two big warnings. One is we can we should plan and expect for massive sea level rise in the short term being 100 years. And by the way, the last time CO2 was as high as it is today, which is 420 to 425 parts per million, sea levels were 75 feet higher than they are now. But it takes a long time, at least from a human timescale, to melt all that ice. But even 10 feet is an enormous amount, would have unbelievable consequences for life on Earth, on human society and civilization. And you say, wow, that seems like such a large amount. During the last ice age, which was only 20,000 years ago, and it was only 100 parts per million less than pre-industrial. Remember, we're at 140 something more than pre-industrial now, but the ice age was 100 parts per million less, and sea levels were 300 to 400 feet lower than today. Florida was 3 times wider than it is now back during the ice age, and there was 2 miles of ice above Boston. So, the world was a very, very different place, and it wasn't very long ago. And the parts per million in CO2 change was smaller than it is now. Again, we're talking about long time scales to melt that much ice, but the danger is there. And again, 5 to 10 feet of sea level rise this century would be utterly devastating. Jim then goes on to say that the good news is you don't have to panic yet, because the oceans, which are sort of driving some of these problems, but they act as a buffer, and they give us some time to take policy action. And while he doesn't go into the policy action in this paper, he has in previous. And one is he suggests putting a price on carbon. That's something that he and I worked on. I actually should put another link in the YouTube description on that paper that we worked on together on why fee and dividend is the best way to price carbon. But that's and I also just think we should just phase out fossil fuels. That's the most effective way to do it. Fee and dividend is the second most effective way. And subsidizing renewables, which is the way we're doing it today, just gets you more renewables. It doesn't get you much less fossil fuels. So that's one thing. He also supports nuclear energy. I think renewables are cheaper now and faster to deploy. But that's fine. He also then is one of the few well-known climate scientists that also supports not doing it right now, but researching solar geoengineering, solar radiation management to reduce the energy imbalance of the Earth. So that's a summary of Jim's paper. And again, this is part of his Sophie's Planet book that he's been saying he's going to finish I have to say, for the last few years. But he is working on it, and hopefully that will come out soon, and we'll hopefully have a chance to interview him about that book. So with that, Leon didn't make it here. I think he would have had some charts and everything to sort of back up all this, but I think I gave you a good overview. I have not been looking at the chat, but we're going to invite Stacy in to see if she has some questions. And let's get Stacy in here right now. Hi, Stacy.
Hi, Dan. How are you?
Okay. I think we can keep this one short if, but we can also
Yeah.
turn it into a Q&A session on this
Yeah,
subject and others.
the chat is, I don't know, there's a disturbance in the force. That's all I'm gonna say. There's not, it's like the vibe is off severely. Yeah, we'll have to discuss later. But the thing I'm excited about is the tiny but mighty solar panel that is going on my roof. It's quite tiny. It's just to power doorbell and camera and things like that.
Oh, okay.
But that
Yeah,
way,
okay.
they have power instead of having to be wired to, and et cetera, et cetera. So
We're gonna hear a lot more about solar on Wednesday with Bill McKibben.
I can't wait. I've been reading about how I believe it's Pakistan has replaced almost half of its residential power by these like DIY, stick it on your apartment kind of panels. And um, IKEA is testing in Germany the same sort of thing. Like, just get this and put it on where there's sun and plug it in, and you can run most of your appliances, etc. And a friend posted about a company locally that's doing that for us here as well. Like, so that you don't have to go through the heavy permitting process, etc. It doesn't require a new roof. It's like someone like me who's renting can just sort of plug it in and go. So I'm
Actually,
very
and Bill will
excited
talk
about
about this,
this.
but in the United States, it costs us a lot more to deploy solar than like any other country. And it's all called the soft costs. It's the regulations and the
Yep.
permitting, where in Germany, it's like all one thing, and you just sign a piece of paper and you do it. And all over the world, of course, the rest of the world, they just buy it and install it.
Yeah.
So that's really kind of dumb. That I think it increases it by like a third of the cost, or like there's a lot we can do to make it better. And now, of course, we're going with the Trump administration. They're going against renewables or stopping wind projects that are 90% complete, just because they're doing the bidding of the fossil fuel industry. And yet, even with all of that, solar and wind are still cheaper than fossil fuels, and getting cheaper dramatically. And I'm sure we're going to hear about that from Bill, especially around the world. And you don't have to build transmission lines, to get the power from a coal plant to where you
Yeah.
are. You don't have to buy coal every day with the fossil fuel plant, you burn it, you get some energy, and then you have to buy more right away and burn it again the next day.
Yeah.
Whereas for renewables, you dig up some minerals and stuff, and you get some lithium, get some copper and stuff, and you build it, and then for 25, 30 years, you have a source of energy where you don't have to dig up anything else. And so that's a pretty dramatic difference, and the cost it's insane. It's dropped 99% in the last like 30 years for solar. So
Mm-hmm.
yep, it's we're gonna have a very exciting thing. And if you have questions for Bill and you want to get them in earlier, so maybe I'll work them into my questions, then go on Bluesky or Twitter and post under with my announcement for the show. You can post your question and things like that. Okay. So I see a question here from Haley Parker. We can pop up here. Do you want to? And let's see, did someone joined us? Leon joined us. Okay, we'll get him on in a second here. Question: given that industrial civilization and overpopulation are causing all this climate change and a lot more, shouldn't we be talking about depopulating and deindustrializing as fast as possible? I think you should call it as soon as possible. Okay. Well, it's actually what's causing the climate change is the fossil fuel emissions. And for example, where most of the population does not Most of the population doesn't emit much CO2 at all. Folks in Africa, I think all of Africa contributes like 3% of greenhouse gas emissions. So while there are issues, and we had William Rees on, I mean, there's certainly an issue of overconsumption and harm to other ecosystems, separate from climate. If we can get rid of emissions, it could solve the climate change. And I think that actually is an easier thing to do than to convince people to depopulate. Although educating women, providing education and healthcare for people automatically lowers the birth rate, and that's actually happening in almost all of the developed world. So if we those kinds of policies, I think, are very effective in lowering population. And in terms of deindustrializing, if you have an idea how to do it, just because there's something we know we should do, it doesn't mean we're going to do it. Like I've been giving talks on climate change saying we must, and I mean must, lower fossil fuel emissions. And I've been saying that for over 20 years. And it's true, because I've used the word must as meaning if you don't do it, we will suffer unacceptable consequences. And so it was true that we must do it. And this was, again, 20 years ago, and we didn't. So we are beginning, and it's only the beginning of experiencing unacceptable consequences. This is what Jim Hansen is talking about here in this paper, what he talked about in our interview. So there's a difference between what we must do and what we will do. So I'm always really interested, because many people suggest this. And if you have ideas on how to actually get the governments or the public somehow to agree to this, when they won't even agree to phase out fossil fuels, which is an easy thing to do because they're more expensive than renewables, I'm all ears. I want to know, because I think it would help, if we could, but I don't see how that's going to happen. Let's welcome Leon. Hey, Leon. Oh, let's get rid of this other thing. Okay. Hi there. Make it happen. Kickstart Accelerate. Okay.
Yeah, just shirt I was wearing. I been quite active in the different startup communities in energy and climate.
Can you get your microphone closer to you, by the way? Because it's a little echoey.
This one? Yeah.
No, it's not. I don't think it is that one. It must be your computer.
Sorry. Let me just do it like this then.
Anyway, it's okay. I can hear you. It's just it's a little echoey.
Yes. So
did you hear my description of Jim's chapter there?
Yeah, I was listening on YouTube. I was still traveling, so sorry I was late.
Any comments? Anything you want to add to that maybe I left out? I mean, it was a fairly short thing, and again, did not go into technical detail because it's, again, a chapter of a book that he wants to be accessible to the general public. So it didn't have the same detail that, for example, his last communications had. Nope, and now you're frozen, Leon. Okay, well, we're going to keep going. Oh no, there you. Can you hear me, Leon?
Yeah, sorry.
Okay, you're back. Okay,
back.
So I think you're back. So, but your videos are getting a little blurry.
Okay, let's hope I will.
But anyway, do you have anything to add to what I said about Jim's communication? Oh, I'm not sure you're hearing me. And I'm not hearing you.
I am, but...
Okay. Ah! Oh, there we go. Okay. So go ahead.
Do you see this?
Yep.
Okay. Yeah, so talking about the energy balance of the different planets, of course, and I thought I'll just simplify it a bit with this graph. Do you hear me and do you see this?
Yep, we can see it and we can hear you.
Great. Yeah, so I didn't have time to look up the albedo of Venus, but I think it's quite interesting that Venus reflects a lot of sunlight. So this Earth, so about 30% or 29% of the Earth's sunlight is being reflected back to space. and then so it's almost 100 watts of energy average over the entire Earth's surface. And then, of course, as Jim also wrote about, is that most of that the temperature is now in Kelvin is causes there to be almost a balance. So almost as much sunlight is being absorbed as is radiated back to space. But that's changing. So more and more sunlight is being absorbed.
On
Of
Earth.
course, because the reflectivity is changing, but also because because of the increase in greenhouse gases, it it takes more it takes time for new balance to be reached. And if you keep increasing greenhouse gas and keep decreasing aerosols, and of course you have these feedbacks, cloud feedbacks, and the surface feedbacks like melting ice, then it takes a while for a new balance to reach. And if you keep increasing these greenhouse gases, it will take longer and longer for a new balance to be reached. And I think that's, to me, this is quite interesting to show how this is changing. You see the sunlight doesn't change much. There's some variability there, but the increase is mainly in how much sunlight is being absorbed and how much infrared keeps being absorbed as well. And the atmosphere of Venus, of course, has a lot of CO2 and a very high pressure, as Jim also explained, which causes there to be much more heat being kept into the system of the planet of Venus, and increasing the temperature further. And I think it was also quite interesting that he had explained, of course, the oceans, the important role of the oceans in keeping the Earth's temperature and Earth's climate stable. Because it takes a lot of heat to warm the oceans, but even more heat to evaporate the oceans. And the average oceans are about 2,000 kilometers deep. So it will really take a while before we would have a runaway climate, even if we would increase these greenhouse gases by much more than they are now. I think if we start seeing these impacts happening, I hope we will get our act together and make sure that we don't have a runaway climate. But yeah, as you explained, we don't see that happening yet. We don't see the actions that are required. We don't see those happening at all.
So speaking of that, one of the questions here is, what's Hansen's key distinction between Venus syndrome and runaway climate, and why does he consider only one a real threat to current generations? So just to repeat it again, the Venus syndrome is the Earth gets a runaway global warming, and it gets hotter and hotter, and the oceans boil away, and you're left with baked dirt, basically, and everything else is in the atmosphere are gone. And
that's 500 degrees Celsius, right? So
500 degrees Celsius. So that is not going to happen. Okay, that's the good news, but okay, not 500 degrees. But he's still saying there are serious planetary threats, including both sea level rise in the relative short term that would wipe out all the coastal cities and et cetera, and also heating to the point where humans can't live in the tropics and subtropics, causing mass migration. And by the way, tons of other problems. Food, access to food, for example, would become very difficult and things. So that's the difference. So the good news is you don't have to worry about 500 degrees, but you do have to worry about other absolute catastrophes from a human society point of view. Not quite as bad as 500 degrees, which is literally all life on Earth is gone. I mean, it's just baked out of the crust. It does remind me of the joke, which I think I told recently on the program, but it's from Saturday Night Live in the 70s. Jimmy Carter is taking a tour of 3 Mile Island. Something goes wrong, and then there's a press conference afterwards, and the reporter stands up and asks the press secretary, "Is it true that the president is 100 feet tall?" And the press secretary goes, of course not. There's no truth to that whatsoever. What? That's ridiculous. And then another reporter stands up. Is it true that he's 90 feet tall? And the press secretary says, no comment. Anyway, so that's sort of what we're talking about. Yes, it's not going to get to be 500 degrees Celsius, but it's still going to be bad enough, I guess is sort of how that story fits in. Okay. And Stacey, do you have any other, or go ahead, Leon?
Yeah, I just want to point out, so there's a lot of albedo to reduce. I think that's important to note, that of course we have a lot of, the Earth has a lot of clouds. Still, there's a lot of clouds, because you often see, of course, images of our planet without clouds, but those are artificial. Those just put together all these pictures of cloud-free days and create this image of the planet without clouds. But if you look at the planet, there's always, I think about 70% of the Earth is covered by clouds on average, and of course it depends a bit on there's different types of clouds, but that's why our planet is quite bright. So reflects, as I show you, about 29% of sunlight. But the oceans, if you have dark oceans, those absorb 90% of the sunlight. So then those reflect much less light back to space. So I think that's really
one of the reasons why ECS is 4.5 degrees. We had George Salutis on, NASA scientist who studied how we're getting less clouds because the planet is warming, which is separate from the work Leon's been doing on, changing ship emissions and getting less clouds because of that. It's just sort of the nature of global warming. You got to figure out how much of is one versus the other, but they're both two big effects, and it contributes to the very high equilibrium climate sensitivity.
Yeah, and I think it's often confusing to people, but the how sensitive the climate is to what we do to the climate, right? How we force it to change, these forcing agents. That's both about greenhouse gases and aerosols. If we reduce aerosols and the sensitivity is higher, that means that by reducing air pollution and reducing the cooling effect of our emissions, if you take that away, then the warming effect of that will also be higher if the climate is more sensitive to any forcing agent, right? Whether it's the sun, or whether it's the aerosols, or whether it's greenhouse gases. Okay. And that's why it's very important to understand the climate, how sensitive our climate is, and that's not just about doubling CO2, but that's about all these different, also about near-term changes. Because if we now cause a very strong forcing increase by both reducing greenhouse gases and reducing aerosols and increasing greenhouse gases concentrations at a record rate, then of course, if the climate is more sensitive than the IPCC and things, then and that's from all these different lines of evidence. Again, the paleoclimate, the climate models, the recent changes, and then now also the different planets, so Venus and Mars, what we can learn from the climate of these other planets. We can learn if the climate is more sensitive to these changes, we should see rapid climate change happening on our planet now as well, and that's what we are now starting to see. If you see that,
we're starting to see that, exactly right. That's why we had such dramatic increase in temperature in the last few years. Hey, we have Eli here, so I'm going to invite Eli to see if he has a comment or question. Welcome, Eli. Are you there? Not hearing you, Eli. All right. Well, we'll get back to you. I'll leave you on, Eli, so you can kind of jump in.
Yeah,
and
Brian,
we're going to bring Brian here when is not here yet, right? No, not yet. We're going to actually have a guest on here in a second.
Hi.
By the way,
I'll have to withhold that for a moment. I need to restart this machine.
Okay. All right. Is Brian joining?
Shall I share it with Brian?
Well, the Eli said he was, or was that you saying that? Oh no.
No, but I don't know if you managed
that was
to
Eli. Anyway, let's cover a few more things about. I see some comments here that want to clear up things. Haley Parker saying, "What's the EROI of those IKEA panels? The energy return on investment. So how much energy do you get for every dollar that you put?" And there's another one, energy return on energy. Like how much energy do you need to make this stuff, and how much energy you get out of that. And it was true a long time ago that fossil fuels gave you more energy, more EROI than solar panels and wind. But that actually is reversed now. And actually, renewable energy has a better EROI than new fossil fuels. So yeah, if you're in Saudi Arabia and you just have a pipe in the ground and the oil's just coming up and nothing else, then then that's a good EROI. But that's not your choice anymore. You have to get the oil from deep in the ocean or go by fracking, and all these things are much more costly. And so we already hit peak conventional oil. I forget when that was, but a while ago. So the easy to get stuff is all spoken for now, and now it's hard to get. So there is still this myth that renewable energy has a lower EROI, but it's not true. You can view a whole program on this on the Energy Transition Show, which if you think our show is wonky here, that's a really wonky show. It doesn't get into climate science. It's much more about energy policy and deploying energy systems and things like that. But they did a whole show on the EROI. And okay. All right. And let's see. Let's go to, we have Dr. Brian here. We one of our first non-interview guests as a commenter guest. And welcome. Good to see you.
Oh, thank you, Dan. I hope my audio is okay.
It sounds good. And it's like the middle of the night where you are in Australia, right? It's like crazy.
It is. It's about 3 a.m. I happen to be up, and I heard your very interesting and inspiring review of what James Hansen had to say and the future. I think there's a couple of really important things to bring in, and that is, Hansen said we are going to actually get a runaway Venus effect after the ocean, parts of the ocean, exceed 40 Celsius. And I thought, oh, that'll take forever. I mean, the ocean's been at 30 Celsius for decades, and it has, for a long, long time. But recently, we've been seeing excursions in the Indian Ocean exceeding 33 degrees Celsius. So we are significantly getting into these excursions where, 40 Celsius is not that far away. And you'd hate to, you'd like to say, oh, we never see 500 Celsius, but you start running into this, if parts of the ocean start hitting this 40 Celsius threshold, you start getting parts of the Earth running into this runaway effect. And we really haven't modeled what happens when that runaway effect takes off and how far it goes. So these are major concerns.
Territory.
Yeah, it's unknown territory. We're in the new abnormal in many ways.
The other really it's going to be a very long time, he said.
That's what we all thought. But I'm glad that.
Well, he didn't think that at first, right? He wrote it in terms of my grandchildren that it would be 500 years.
Right. And I'm glad that Hansen has come in and said, there's the ocean means that we have a buffer. We've got more time. But the problem is the ocean provides delayed and amplified feedback. So it's not like it's going to be better. It's just going to be delayed, but it's going to be amplified. And that's a big deal. And we're seeing that with the moisture levels right now.
The actual words on this are runaway. And you're talking about the Venus runaway now. Runaway cannot occur until after the sun is bright enough to drive the loss of Earth's ocean. And the very soonest that will occur is several 100 million years in the future. The Venus syndrome is not an issue for today's young people. That's a quote from his chapter of his book here.
Okay, that's good to know. There was a previous analysis, and I think 40 Celsius is a critical temperature for the oceans. And ironically, I think we've eroded around a third of that in the last few years or decades. That I was astonished to see summertime temperatures in the Indian Ocean exceeding 33 Celsius. And that's open ocean. And it represents a serious erosion of the margin we have before these kind of runaway effects really take off.
But I think he was also saying again about the hydrogen, like it has to escape Earth, and it's not going to happen until.
Yeah, it's not Venus syndrome, but I think it's really important to note
still
that
bad enough.
Bad enough.
We have this. Of course, we had a climate that was much colder than, for example, the last interglacial, the Eemian, the past 10,000 of years. And now, within 100 years, we went from colder than the Eemian. Then oceans that are warmer than they were during the Eemian, and likely than any time in the past million years. So within 100 years, we surpassed anything any climate that's happened in a million years, and of course temperatures are increasing, ocean temperatures are increasing at a record rate if you look at the trends, right? So
yeah, I would agree with you there. And I think there's a key aspect to all of this, and that is the sea level rise. It's not a linear increase, it's a parabolic concave up increase. And that, along with methane emissions, which kind of flattened out around 2010, but now are going parabolic again, and they're increasing more and more each year. Between sea level rise and methane emissions, I think we're looking at some serious concave up, delayed and amplified feedbacks. And that's something I think we need to really look at and furthermore take action on.
We are reaching a forcing this century that is likely higher than anything in the past 500 million years, because the sun is increased. The power of the sun is increasing, as Jim also wrote about in this update, and we also wrote about that in global warming in the pipeline in our study that was published in 2023. So the sun is brightening, and of course we emit certain greenhouse gases that have never existed in the history of our planet.
Yeah.
And then we increase methane and of course CO2. So we are reaching really something that has never happened, of course, in the history of our planet. Of course, the rate of change is unprecedented, but even the forcing is likely unprecedented for about 500 million years.
I agree with you. And sometime
within a geological instant.
Yes, I agree with you there, Leon. And as a preview, I'd love to come back and discuss not only problems but solutions. Here in the Western Pacific, we've been working on something we call marine permaculture, which we believe are actually going to address all three legs of the climate triad, and that is emissions to zero and 2,400 gigatons of carbon removal, because we're going to have to deal with the carbon coming out of the ocean and the soils on the way down. And finally, climate repair. And that starts, of course, with local and regional marine cloud brightening. So I'd love to come back sometime and dive into literally what we think may be the deepest tech for near-term changes, hectare by hectare. Within 12 months, we hope to have a commercial scale hectare of marine permaculture running.
So we're going to have you on sometime when you're going to agree to get up at 3 a.m. again. So
that's the hard part, is predicting it.
Have that discussion. So I want to go. Yes. We have some other questions. A lot of stuff irrelevant.
Thank you, Brian.
But here's one interesting question that people maybe haven't thought about. What is the total energy release from all the combustion that drove levels of CO2 to 420 ppm compared to the energy of radiative forcing from CO2 since the Industrial Revolution? And the answer is it's very small compared to its. I don't remember the exact number. Maybe if it's 1%, it's on that order of magnitude, or maybe less. So the amount of energy that has warmed the Earth so much so far, and the energy imbalance today is roughly equivalent to what is it? A million Hiroshima atomic bombs going off each and every day. That's how much is heating the Earth compared to the essentially everything we do to use energy all turns into heat eventually. So versus that heat, and that heat is a tiny, tiny fraction of the. Now there's a worry that if we keep doubling our energy use and doubling and doubling and doubling, eventually that 1% becomes 2 and becomes 4, and then it becomes a significant amount of heat just on its own. So no climate change, just the heat generated from all the energy. And it would be different, by the way, if it comes from fossil fuels or nuclear, that would be new heat. If it comes from solar, it comes from the energy of the sun hitting the earth anyway. And so it wouldn't necessarily contribute the same way, because that was going to heat the earth anyway, and we just captured it and used it as energy, and then it went back to heat. And same thing for
Depends a
wind.
bit on where you put the
Same thing
solar
for
panels, of course.
Yeah. So anyway, so that's a quick answer to that question. And let's see.
But I think it should count as a forcing. I think that's.
Oh, I see. Yeah, it is.
It's almost as much as the effect of contrails. So and of course it's regional. So of course in your house, of course you heat your house, and then of course that adds energy to your house, and then your house warms up, which is of course the goal of if you want to heat your house. But and you see cities are warmer, and that's in part because of all heat from the sun, and because there's less trees and it absorbs more sunlight, but also because there's a lot of energy generated in cities. So you do have these regional warming effects, of course, from energy use. So it should be taken into account, and it often is. In the 1972, in the limits to growth paper published by the Club of Rome, this was noted that if we keep increasing how much heat we produce, that could cause warming, and of course we do see that, but it's totally indeed, as you mentioned, overshadowed by the greenhouse gas keeping all the heat in.
Yeah. By the way, we have Eli, I think, back with us. Eli, you're on. Can you hear us, and can you speak?
Yeah, can you hear me okay?
We can hear you now. So, hi, do you have a comment, question?
Well, so it's kind of related to the comment that Nadia raised about different versions of scenarios in the extreme warming, where we have much more water vapor in the atmosphere, to the point that much less thermal energy ever makes it to be radiated back into space, that is out of the Earth climate system, and you can get there well short of boiling off all of the oceans. So something that's not as hot as Venus, but much hotter than anything mammalian life has been used to, with some liquid water still. That's close enough to Venus to be worried about.
I agree, Eli. That's a big concern in the long term.
Okay. And I'm looking for a comment. Let's see. This is, I didn't read this yet, but someone suggested, okay, from Nadia, is 45 to 47 degrees for global mean surface temperature to hit the moist greenhouse, and that's short enough for the Simpson Nakajima that it takes millions of years to accumulate the heating effect. Leon, do you understand this one, and or Brian, able to address it?
Yeah, that's within the error bars. In the 40s, terrible things happen. We're not there yet. I think we've got time to try to reverse it, but I think your point is spot on. We must phase out fossil fuels or face unacceptable consequences, including the destruction of most of the civilization.
Right. But, only that. It is kind of amazing, actually, that we know this stuff. It's okay. People didn't believe it. They didn't see it. Now they kind of see it. Now they see it's coming. We're pretty sure about the sea level rise. I mean, we might be off. There's a little question about when, but there's really no question about the total amount. But if it's sort of past people's current lifetime, they don't even care. But it's now no longer that. It's your children's lifetime, 2100, 75 years away. And forget that, 2050, we could see like a couple of feet of sea level rise would be unbelievably damaging to many places. and make hurricanes much worse and get the storm surge much worse and on and on and on. But 5 to 10 feet in 75 years is absolutely insane. And
Right.
we know it. It's not like well, there's some deniers out there, but including in the government. But you ask a climate scientist, say, yeah, that's absolutely a possibility and likelihood if you ask Jim Hansen.
Not only that, world leaders have been informed of this by their scientists, well before it became the public topic that it is now. And Margaret Thatcher, despite her political, which side of the aisle she's on, she got it. She realized that this was really, really a really big deal that we absolutely have to do something about. But most of the rest of the leaders just, said, well, this is in the future, and we'll just roll the dice for a while longer, and we'll see later.
Well, Lyndon Johnson was warned.
I'm sorry.
About it
I'm sorry. Margaret Thatcher got something right. Is that
she got 2 or 3 things right? Yes.
Okay.
One little ray of hope is that I heard that China installed 93 gigawatts of solar in May 2025, which it's necessary. We must phase out the fossil fuels. I'm encouraged with that rate of adoption internationally.
We'll hear more about that on Wednesday with Bill McKibben. And
good.
And along those they're lines, putting in essentially a nuclear power plant worth of energy every day or every hour, some crazy number like that.
It's amazing.
And maybe it's not sure yet, but that maybe the 2025 is the first year that China actually drops its emissions. I mean, not a lot, but maybe it doesn't grow. And that would be they said 2070 is when they promised to do it. So that would be a huge thing. And they're going to take over this. The country that has the cheaper, cleaner form of energy is going to win in the global economic race. And the United States is just, who invented all this stuff, by the way, is just disarming itself from the fight.
Here in Australia, the federal government has committed and is committing to 82% renewables by 2030. So huge transformation, and really happy.
California is
good.
But not the country in general. So, all right. Look, we did it. It's 11:02, and I thought this would only be 30 minutes because that's sort of the time it took to cover Jim's paper. I want to, unless Stacy or Brian, Leon, or Eli have any final comments or thoughts, I want to thank everyone for coming. We never do this enough, but please like, subscribe, hit the bell notification, make a comment in the comments, like, are you concerned about what Jim Hansen's writing about? There's a lot of stuff in the chat here. Put those in the regular comments on YouTube. If you have questions for Bill McKibben, put them in Bluesky or Twitter announcement of that show that I posted Wednesday, September 3rd at 10 a.m. Pacific time. Bill McKibben talking about his new book on solar energy, and that'll be great. We'll have Brian on to talk about the ocean sometime soon. And I want to thank everyone for coming. And we will see you next time. Bye-bye.
Thank you.
Wednesday.
Thank you, Dan.